Morning everyone. Let us start this session. So today we will start with the module number 3 from your syllabus, which is a friction. So this is the content of the module 3. So first we have the revision of a static friction, then dynamic or the kinetic friction. Then we have some definitions for coefficient of friction, angle of friction, laws of friction, then concept of cone friction. Then we have the equilibrium of the bodies on the inclined plane. So these are the problems on the friction. So by using the conditions of equilibrium, we will try find out the friction force or the pull force required to cause the motion. Then last, we have the application to the problems involving wedges and the ladders. Okay. So this is the overall content of the module 3. So let us see what is meaning of friction. So friction is defined as the force of resistance acting on the body which prevents the slipping of the body relative to second body or the surface in contact. Okay. So friction is developed between the two contact surfaces when one surface tries to slide over the other surface. So basically the friction is the force of resistance. So force of resistance which is offered by one surface to the other surface in contact, this is called as a friction. So friction force always acts tangent to the surface in contact and it in opposite direction to the direction of the motion. Okay, so here you can see one example. The person is trying to push the object in this direction. So this is the positive x direction. Okay, and the friction between this ground and this contact surface or the surface which is sliding over that ground. So this is the direction of the resistance. This is the frictional resistance. Okay. So frictional resistance is opposite to the direction of motion of the object. Okay. And it is tangent to the contact surface. So if you observe these contact surfaces, then this is the tangent resistance. Okay. So this is called as a friction or the friction force. So what is the reason for the friction? So if you observe the contact surfaces under the microscope, then you can see such type of engagement. Okay. So each surface, even though it appears as a smooth surface, so if you just observe the surface, then it will appear as a perfectly smooth. Okay. But under the microscope, if you observe, then you can see such type of irregularities present on the surface. Okay. So these irregularities, they cause the interlocking. Okay. So you can see the interlocking between the two surfaces. Okay. So because of this interlocking, when we are applying the force on the object, so this surface will try to slide in this direction. At the same time, this surface will offer the opposite force. Okay. So this opposite force will act in this direction. So therefore, we take this in a tangent direction to the contact surface. Okay. So this is the reason why the friction force is developed between the contact surfaces. Okay. So use of friction, some useful we can say effect of the friction is here you can see first. So we can walk or we can run on the ground just because of friction. Okay. So here basically we are applying the force. Okay, in the backward direction. Okay, and the friction will offer the opposite force, that is a reaction. So useful effect of the friction is we can walk on the ground due to friction. Okay. Second is the wheels of the automobile, they can roll on the road surface because of the friction. Okay, so here you can see. So when we drive a car or ride a motorcycle or a bicycle, then the wheels are in contact with the road surface. Okay, so wheels are rolling in this direction. So right now it is a clockwise. Okay, so here I will show. So this is the wheel of the automobile. During its rolling motion, this is the clockwise direction. Okay, so wheel will create the force on the road surface in this direction. Okay, and because of rolling motion, the complete vehicle is pushed in the rightward direction, and this is because of the friction. Okay, so the road surface, it will offer the opposite reaction. So this is the applied force. So you can see force on the road surface from the tires. Okay, its direction is right now it is a negative x direction. Okay, road surface will offer the opposite reaction in the forward direction or in the positive x direction. So this is the friction offered by road on the wheel or tire. Okay, and because of this force, we can move in the forward direction. Okay, so this is one useful effect for the friction. Sometimes the friction, it will create the problem. Okay, so in case of rotating machines, okay, suppose we have one shaft and which is used in some mechanism. Okay, and it is rotating with some angular speed or RPM n. Okay, so this rod, it is fixed in some collar or the bearing. Okay, so because of the continuous rotation, it will create the friction at this contact surface. Okay, so this friction is unwanted. Okay, we are not expecting this type of friction, and this friction will create the power loss. Okay, so in order to minimize this power loss or order to reduce the friction, we need to add some lubrication. So here we are adding the lubrication in order to reduce the friction. Okay, so this is all about the concept of friction. Now here you can understand the friction, how the friction forces develop at the contact surface by considering the motion of a block. Okay, so here I have taken one block and it is resting on the horizontal surface. Okay, so here if I apply the force F on the object having some mass m, then immediately the friction force, it will come into existence. Okay, and if there is a motion because of the force F, then friction, it will try to oppose that motion. Okay, so for the motion, we need to overcome the frictional force by applying the external force. So if the external force is greater than the frictional force, then we can see there is a motion of the object. Okay, so now we can see how to draw the free body diagram for the same object. So in the free body diagram, you will have the first force, which is the force due to gravity. So if the object is having the mass m, then the corresponding force, this will be mg. So this is the weight force. So it is acting in the downward direction. Due to this weight force, the surface on which the object is resting, so right now it is just a ground. So this surface will offer the reaction exactly in the opposite direction to the weight force. And this is the normal reaction, which is a N. Okay. And suppose we apply some external force on this object, then there will be frictional resistance, which will try to oppose the motion. Okay, so this is the frictional resistance. Suppose we just keep the object on this ground, having the mass m, there is no external force, then its free body diagram will be like this. This is the weight force, which is the mg acting in downward direction, and this is the normal reaction offered by the surface. Okay, so in this case, as there is no external force, there will not be any frictional force. Okay, so always remember, if there is a possibility of motion, that is called as a tendency of motion, then there will be frictional resistance. Okay, otherwise, if the object is just resting on a flat surface, then we will not show any frictional force. Okay, because this object, there is no possibility of motion. Just imagine another case. So we have one inclined surface having some inclination theta, and we have kept one object on this surface. Okay, and this object is not moving in the downward direction. Okay, so even if the object is not moving in the downward direction, but there is one force acting in this direction. Okay, so it's that force will be, so initially this is the weight, which is the mg. Okay, it's one component, it will act along the plane, and one component, it will act normal to the plane. Okay, as this is theta, so this angle is theta. Okay, so this component will be the adjacent component, which is equal to mg cos theta, and this component, it is the opposite component, so this is mg sin theta. Okay, so mg cos theta, it will create the normal reaction like this. Okay, and mg sin theta will act as an external force like this. Okay, so even if the object is not sliding down the plane, there will be one force which will oppose that motion, and that force will be the frictional resistance. Okay, so as long as this mg sin theta is balanced by the frictional force, object will remain in the stationary position or in the static condition. Okay, so if the frictional force or this external force, so it becomes greater than the frictional resistance, then the object will start its motion in the downward direction. Okay, so here you can understand the friction will be developed if there is some external force or if there is a tendency of the motion. Okay, so this is the free body diagram about the friction. So here you can see, if you observe the contact surfaces between the two objects or two surfaces, okay, under the microscope, then you can see such type of irregularities. Okay, so these irregularities, they will create the interlocking, So actually your surface will be like this. When it is in contact with another surface, so you will have the interlocking like this. And whenever we apply some force on one object, other object will create the opposition. Okay, and this opposition or the resistance, this is called as a friction. Okay, so now we will see the relation between the external force and the frictional force. Okay, and when an object will start its motion when we apply the external force. So just imagine there is one object which is resting on the ground as shown in the figure. Okay, so this object is having some mass m, and imagine initially there is a zero force. Okay, so this force so on this object initially we apply the just zero force. Okay, so when we apply the zero force, that means there is no external force on this object. The frictional force, it will be also zero. Okay, so your graph, so here you can see the x-axis is the external force, okay, that we are applying on this cable. Your y-axis is the frictional force, so the force which is created at this contact point. Okay, so your graph will start from this zero value, that is origin. When the force is zero, external force is zero, frictional force will be zero. As we go on increasing this external force, 1 Newton, 2 Newton, 3 Newton, so on, then up to some limiting value, okay, the frictional resistance will increase. Okay, and there will be one limiting condition. After that, the object, it will come into the motion, that is a dynamic state. Okay, up to that limiting point, object will remain in the static condition. So here you can see that limiting condition, and at that limiting condition, the frictional force offered by the surface will be maximum. And this maximum force, that is the maximum frictional force, it is called as a limiting frictional force. Okay, so here you can see that condition on the graph. So just imagine from 0 Newton, we start increasing the external force. Okay, so we apply 1 Newton force, 2 Newton, 3 Newton, so on. So you can see on the y-axis, the frictional force, it will increase in the same order. Okay, so we apply 2 Newton, so frictional force will become 2 Newton. Okay, simultaneously observe the points on the graph so that you can understand. Now if I applying 3 Newton, your frictional force will be 3 Newton. For 4, frictional will be 4 Newton. So you will get one straight line graph like this. And there will be one limiting point. And after this limiting point, the motion of the object will start. So right now, just imagine the 9 Newton is the limiting value. That means when we are applying the force 9 Newton, which is the external force on the cable, the frictional force, it becomes 9 Newton. Okay. After this value, even if I increase the external force by 0.1 Newton, the object will immediately start its motion. So if the force becomes 9.1 Newton, okay, that is the external force on the x-axis, the friction, it will be less than this 9.1, okay, because this surface having the maximum capacity of offering the friction, which is equal to 9 Newton only, okay, and therefore the external force, it becomes greater than the frictional force, and therefore this object will start its motion towards the positive side. So that you can see here. So this condition, that is called as the limiting condition, this is called as a verge of motion. Okay, the meaning of verge of motion is this is the last static condition. After that, object will completely start its motion. That is the dynamic state. So you can see if the force becomes 9.1 Newton, okay, then object will start its motion. So this is called as a dynamic condition. Okay, so up to this value, that is the limiting frictional force, which is a F max, object remains in the static condition. That is your static equilibrium. Okay, so this is called as a limiting frictional force. Okay, so now what will happen if you continuously increase the external force? From right now we have applied 9.1, after that 9.2, 10, 11, 12. So for all these values, object will be in the dynamic state only. That means it is completely moving. Okay, so increasing the force, it will increase the velocity, or it will increase the acceleration as per the Newton's second law. F is equal to mass into acceleration. Okay, but the friction, when the object is moving, so that friction will be less than, just I will write the friction or the frictional force in the dynamic state when the object is moving, it will be less than the frictional force when object is static. Okay, so this is called as a kinetic friction. Okay, and this is the static friction. So that you can observe on the graph. So when the object is moving, there will be some friction. It doesn't mean that there is no friction. When the object is moving, friction will be there. Okay, but that friction value will be less than the limiting frictional force. So limiting frictional force means what? It is the maximum force in the static condition. So on the graph, you can see when the object is moving, and if you increase the external value, that means this value, then you can see there is a drop in the friction. Okay, and after particular value, the friction will remain constant even if you increase the external force. Okay, so this constant line, this is called as a kinetic friction. So it is represented as a Ft. So this is the frictional force when the object is moving. Okay, and it is always less than the limiting frictional force. So F max is the maximum friction that the surface can offer to the object. So from this graph, you will get two regions. This is called as a static. Up to this point, object is stationary. Okay, and this region beyond this line, this is called as a kinetic or the dynamic state. And the friction here, we call this friction as a kinetic friction. Okay, and remember, kinetic friction is always less than the static friction, which is a F max value. Okay, so this is kinetic force of friction. So here you can observe that motion. Okay, that is a static region and the kinetic region. So this is one animation. So just I will draw the graph. So here we have the friction force and this is the external force. So here we can see one arrangement. This is one object, okay? It is having some mass m. Then here we have connected one pan, okay? And this pan is connected to the object with the help of this string which is passing over this smooth pulley. Okay, so initially there is no weight, so there will not be any friction at this contact point. Okay, if you add some weight in this pan, let us take this W1 Newton, okay, then there will be some frictional force. Okay, so it doesn't mean that when we add some weight, immediately object will start its motion. Okay, so initially friction will try to oppose the external weight. So this W1, it will create the force in the cable. So it will have the same value W1 because the pulley is frictionless. So tension will be same on its both the sides. So this W1, it will try to pull the object, but this friction will try to oppose the motion in the rightward direction. Okay, so we have to find out the limiting condition. So here you can see initially you will get the graph like this. Okay, and this is your limiting value. After this limiting value, the friction will reduce and it will remain constant after a specific value. This is called as a kinetic friction. Okay, so we have to find out this limiting value from the experiment. So physically you can conduct the experiment like this, where you can connect one pan, you can connect the cable to this weight, okay, and then you can gradually increase the weight in the pan. So just imagine we are adding some initial weight, okay. Suppose this initial weight we start from 10 gram, okay, or in terms of Newton, we can take this as a 1 Newton. So when we add the weight in the pan 1 Newton, immediately there will be frictional force. Okay, so it will have the same magnitude, 1 Newton only. So this friction, this will have 1 Newton value, which is equal to the weight in the pan. So this friction will try to keep the object in the stationary position. Now we will continuously go on adding the weight. Again 1 Newton. So total weight will be 2 Newton. Okay. Again we add some weight. Again the frictional force will increase. So here you can see in the graph. So we started from 0 value, then 1 Newton, 2 Newton, 3 Newton. So the surface has capacity to offer the same frictional force as we are applying the external force. Okay, so in this way we can increase the weight gradually and we will reach to this limiting value. Suppose it is a 4 Newton. So friction force will become 4 Newton. Okay, and after 4 Newton, if you add a very small weight, then you can see there is a motion. Okay, so this is called as a limiting condition. So before this weight, so just imagine that weight, it was here. Okay, so this is the limiting condition. So when the external weight, that is the weight in the pan, that was equal to 4 Newton, the friction was 4 Newton only. Okay, beyond this point, if I increase the weight by 4.1 Newton, that means if you add a very small weight 0.1 Newton in the pan, immediately you can see there is a motion. Okay, so this is the dynamic condition and this is the static condition. So this is small weight we have added, and immediately because of this weight, object started its motion. Okay, so this is called as a dynamic condition. Okay, so in the experiment, so actually you have one experiment on the friction to find out the coefficient of friction. Okay, so there is a similar arrangement. So from the experiment, you can find out the frictional value. So I hope you have understood the graph, what is the static region and what is the dynamic region or the kinetic friction. Okay. So when the object is moving, there is some frictional force on the object. So here there will be frictional force when the object is moving. So this frictional force, this is called as a kinetic friction. It is represented as